Hello, this is our day 2 tutorial on continuous domain. And we're just going to remind ourselves from previous lessons that domain are our x values. And our x values, we're going to look at graphs, come from our x-axis. I'm going to use my green highlighter again to highlight my x-axis numbers and make sure I'm always using those for my boundary numbers. And I've got my boundary highlighter again because I need my left boundary and my right boundary. So if I go all the way to the left, and look at where does that line up. It doesn't go any farther to the left than that. Where does that line up on the x-axis? That is at the -3. So I'm going to draw my line up to it to kind of highlight it and put my number down below. Then I'm going to do the same thing with my highlighter. I'm going to find my right boundary. So all the way to the right to that endpoint. And this time they both line up on the endpoints. Um, and that one's at the +4. So I'm going to draw my line down there and highlight that. And I'm going to remember x is all the numbers in between those two. So I've got my two boundary numbers. I know that domain is my x numbers. And then from yesterday, we remember that we use less than symbols as our symbols to show that it's everything in between those numbers, the -3 and the 4. And now we've just got to decide if anything gets an underline. Remember, if there's a closed-in dot on one of the boundary numbers, or it actually touches it with a line or curve, that's the same thing as a closed-in dot, and you underline it to show that it includes that number. The -3, the dot on that one was a closed-in dot, so I need to underline the symbol here to make sure that I know that it includes that. The 4 had an open dot. An open dot means it doesn't actually touch or repeat it, so we don't underline it. So it's everything in between and including a -3 up to but not including the 4. So we can say all numbers greater than or equal to the -3 and less than the 4. Now we're going to go down to this next one. I'm going to move my highlighters with me every time. I'm going to remember that I'm looking at my x values, and I'm going to use my boundary highlighter, slide all the way to the left right here. That's the farthest left that it goes. That's actually the 0 on the x. I don't even have to draw a line to it because it's actually on the x-axis, but I will label it here, and I'll write my 0 down low. And then when I try to do my right boundary, some people would go to here and say, well, that looks like that would be at the 6, but that's actually not a dot. It's not a point. That's an arrow. An arrow means that it doesn't actually stop there, so that's not a boundary. We could, if we had a bigger graph, keep drawing it out from there and just go on and on and on, but eventually we run out of space. So we use an arrow to show that it just keeps going on and on and on forever. So we don't have two boundary numbers like we did before. We only have one boundary number. Now, if we have two boundary numbers, like this one has the -3 and the 4, we say that that's fully restricted. It's everything just in between those two spots. Okay. If we only have one boundary number, like this one, we say it's partially restricted. And when we start to write it, since we only have one boundary number, we put the letter on the left and the number on the right, since we read left to right. And we got to decide what kind of symbol to use. Before we were using less than symbols, but here we could either use a less than or a greater than. Well, let's look at how this graph works. Since it's literally going, I'm going to use a different highlighter. Since it's literally going up like this, all the way to the right, that's the same thing as if it were shooting out from the origin that direction. So everything just to the right, and if I sort of move that highlighter again so we can see it a little bit better, if it's going this way to the right, that's the positive side of the x-axis, and all those numbers that are highlighted, that were highlighted here in purple, are 1, 2, 3, 4, and 5. Those numbers are all greater than 0. So I'm going to use my greater than symbol. And since it started off with a closed dot, I'm going to underline it. So it's all the numbers greater than and equal to 0. And then my last one looks like this. And again, we are still looking at the x-axis. But if I pull down my boundary highlighter, If I try to go to the left, I end up kind of like right here. But again, remember, that's not a point, that's an arrow. So that means it keeps going on and on forever. So if I kind of try to draw on and on forever, but you see it doesn't just go straight down, it sort of comes out too. So it's also going to the left. So from there, it's going to the left and it's shooting out to the left side, never stopping. But then it's doing the same thing on the right side. Because if you look on the right side, I also have, if I move this boundary marker, I also have an arrow up there on the right side. So that's the same thing as this thing coming up, but then also going out to the right a little bit. So since it's also going out to the right a little bit, that's the same thing as it coming from here and shooting out to the right side and never stopping. So literally it never stops to the left and it never stops to the right. So if it never stops either direction, it's just shooting down the left and the right side of the x-axis, then we say that that's all numbers. It has no boundaries. There's no place that it stops. So we just say all real numbers. This is an unrestricted graph or an unrestricted domain. And the other way that we can write all real numbers is an R, sort of like with a double line. So we've got three types here. We've got fully restricted with two boundary numbers. We've got partially restricted with one boundary number. And then we've got unrestricted, that is the all real numbers because it's got no boundary numbers.